Hi everyone, welcome to the webinar. This is Generate ROI on Big Data Workloads leveraging Azure Data Services. And this is a joint webinar with Motiveworks and WANDisco. I'm seeing a few more attendees kind of roll in. So as we get more attendees, I just wanted to take this time to thank everyone for registering and attending. The webinars are pretty frequent with Motiveworks, and so feel free to check out our website for more webinars that are coming up. But thank you for registering for this one, and you will all receive this video recording at the end of the webinar in an email 24 hours after this. So be on the lookout for that. All right, so I'm going to go ahead and introduce our presenters. We are lucky enough to have both Tarun Agarwal and Adam Diaz presenting with us today. Tarun is the Director and Practice Lead of Data and AI at Motiveworks. He helps with modernizing the data platform, helps with cost-effective solutions by leveraging data as a strategic value. He's focused on enabling customers to leverage data, analytics, and AI for digital transformation. And all of that is pretty much done through the Microsoft Azure data platform. And then we are also lucky enough to be partnering with Adam Diaz, who is the Director of Partner Solution Architecture at WANDisco. Adam is a technologist working with the Hadoop and big data, and he works with a lot of other areas of technology as well. And we are really happy and lucky to have two leaders in their field to present with us today. So thank you, Tarun and Adam, for taking the time to present. So just a quick agenda for what we're going to go over today. As the title says, we are going to go over sort of, how to generate ROI on the big data workloads. We'll go over how Microsoft is driving business value using Azure Data Services, the best practices to execute big data migration, different approaches to minimize risks and delays, challenges in HDFS data migration, and the optimal way to achieve zero distribution and zero data loss migration. So without any more delay, I'm going to go ahead and turn it over to our presenters, and I hope you guys enjoy the webinar.
Thanks, Sarah. Hello, everyone. Good morning, good afternoon, good evening, depending on wherever you are joining us today. I thank you for your time, taking the time away from your busy calendars. And first and foremost, I hope everybody is doing well and their friends and families are doing well and staying healthy and safe in these uncertain times. So I wish everybody the best of health. So let's jump into today's presentation about how do we really leverage Azure Data Platform for migrating your big data workloads and generating the return of investment that is required for a huge investment that is made for big data analytics kind of workloads. So let's understand what some of the challenges we are facing in this big data analytics workload that has been now running for the last 15 years or so. So Hadoop technology, primarily that is what we associate with when we talk about big data analytics. So those Hadoop technology, which is now being used for almost 15 plus years nowadays, they were good in whatever they were providing and adding a lot of value, but they are now turning out to be becoming an IT debt. Almost whenever we talk to our customers, we hear loud and clear that they spend a lot of their time and energy just maintaining their Hadoop infrastructure and just keeping the lights on, running the day-to-day jobs and the workloads that is running. It takes a lot of IT resources to really manage. And the cost of managing this platform is constantly rising. Mostly nowadays, I think with the consolidation of the industry in Hadoop, we are mainly talking about Cloudera has become really the main provider for Hadoop technology. The cost of licensing for Cloudera is continuously rising. In addition to that, the cost of infrastructure that needs to run the Hadoop platform is also becoming very, very high. And number of resources that is needed requires a large number of team, and the cost is raising very high. And when you compare it in comparison with the cloud technologies, it's really a no-brainer that why would we invest millions of dollars in running a platform that is not generating the kind of return of the investment that is being made in this area. On top of that, the business is moving very, very fast. The new industries like fintech and insurtechs are coming up and fast, very, very fastly. And business is really looking to compete against the rise of these technology companies coming into all the industries, not just financial services. And business is looking to come out with new services, new products, new areas of business, and they are looking to come as early in the market as possible, and they're looking for the agility from the technology teams to drive that competition in the marketplace. And the big data analytics that we are really depending on is becoming a problem because it takes long time to bring a new workload in the market, to add a new nodes into your existing Hadoop cluster for the additional workload that business is trying to run. Takes 3 to 4 months just to get the environment and infrastructure set up. That's a long time, and somebody else can take the market away from you before you even come to the market. And more and more work is being nowadays is getting developed through artificial intelligence and machine learning, and bringing like the emerging technologies and innovation in the product and services. And the on-premises Hadoop environment really lacks that integrated way of doing machine learning and artificial intelligence kind of technologies in using the existing platform. So let's look at what are some of the specific challenges that we face in the Hadoop environment. So the value proposition of Hadoop environment was to really build a data lake and move away from the traditional data warehousing and business intelligence that people have been doing for the last 30 plus years. The concept was really great. You bring in all your data into your data lake, you store all the data, and then you analyze all the data. Now, when I say all the data, I'm using the word loosely. What I really meant by that is whether it's a structured data generating in your own firewalls, from your own systems of records, whether it's relational data, non-relational data, unstructured data, audio, video, images, any kind of data that you have that you would like to analyze. You can bring in all into a data lake, which otherwise in a traditional data warehousing world was not possible. We are mainly talking about building data warehouses using relational data or structured data. So the concept was really great for building data lake, but then the technology brings some challenges because it does not provide that atomicity of the individual at the transaction level, and the data integrity becomes a challenge. To highlight few of the challenges that are typically faced in a Hadoop data lake kind of environment is, as you are trying to write the data into your data lake and other people are trying to read, because it does not provide the atomicity, you will get dirty reads, and the data is, depending on what time you are querying, your results will vary. And there's no really good concept of updates and deletes in data lake kind of a world. So if you're trying to update any data or remove any data from your Hive data tables, it's really very, very difficult to do that. And if you are running workloads in your Hadoop, whether you're running Spark jobs or Hive workloads, and for whatever reason the job fails, it's going to leave the data in a corrupt state. And to clean the data back and come back to consistent state requires a lot of IT resources to do that cleanup and get you back to the data. If you are trying to run both data in batch mode versus real-time streaming mode, the Hadoop world will give you two different environments. You are dealing with one set of environment where you have the batch data and the real-time data is coming through the streaming world. You cannot really unify them and really have a consistent analytics on both the data together. The other big challenge is, as you start using Hadoop environment, over a period of time, you will start to accumulate incremental files into your data lake, and your throughput is going to become slower and slower because you have added a lot of small files in your data lake. So your throughput is going to become slow. And by definition, the data lake concept was to bring all the data, and then the small file is by definition is going to be a part of your data lake. So if that becomes a challenge, that's really a problem that we have. So let's understand how cloud can solve some of these challenges that Hadoop environment creates. So public clouds and the cloud offering in general has established as a de facto platform to provide you the agility and the scale that is needed to run today's businesses. All the cloud environments, regardless of which cloud we are talking about, provides you the dynamic scaling. You do not have to think about what is going to be a peak workload at the beginning of your initiative. You can start small and you can grow on as you grow in your initiative. So do not have to spend and provision your infrastructure for peak capacity. And as the new workload gets available, you can dynamically scale up and down in a cloud environment. It gives you the speed because it is all optimized platform as a service that gives you a lot of automation and the on-demand compute capability to run your data and the workloads at speed that is required to run today's businesses. And you only pay for what you use in a cloud environment, so it becomes cost effective and you do not have to invest large upfront investment. It becomes a really value proposition becomes from capex to opex in a cloud world. So when we talk about migration of Hadoop workloads into cloud, and specifically in Azure cloud, what are some of your options and how you should be thinking about? So the first and foremost option is really infrastructure as a service offering in Azure, where you can rehost your existing Hadoop infrastructure environment into Azure VMs. And you can get the benefit of the cloud by getting you the agility and the scale. You can, if you have to add a new nodes into your cluster, it's a very easy and straightforward in a cloud world. With the flip of few buttons, you can add additional VMs into your environment. You can also scale up the environment, so it gives you the agility and the scale. In a rehost, it will be fast, very easy, because you're just moving your environment as is. But it will not give you the solution for some of the Hadoop data lake challenges that we just reviewed recently. You will continue to run the same environment in a rehost kind of approach, as well as you will require the large number of IT resources to manage your infrastructure. But you can, if you are looking to reduce some of your IT resources and better cloud platform use, then you can go into a platform as a service offer, which is going to be a refactoring of your same Hadoop workloads into running as a platform as a service into Azure HD Insights, which is going to give you the managed Hadoop platform. It's the same open source Hadoop platform, but now instead of your resources managing the clusters, it's going to be taken care by the Azure platform as a service offer in HD Insight. But again, here also, because you are still using the same Hadoop technology, the data lake challenges that we talked about still stays in this world itself. The next option and the best option is really to reimagine the big data world. So moving away from Hadoop technology and really embracing the cloud native services, which is optimized for cost and performance and gives you the same big data analytics and the unified experience of working with any kind of data together. And primarily, we are talking about using platform as a services offer from Azure, like Azure Databricks, Azure Synapse Analytics, Azure Data Factory, those kind of things. So we can re-architect your platform, and that gives you the better performance and much more optimized cost. So what are some of the value propositions we have really to review some of the things that is available as a part of Azure Big Data platform? Basically, you're moving away from managing infrastructure. You can directly start using the cloud native services and do not even have to worry about the servers, or I need to manage the infrastructure, I need to do upgrades and hotfix and patches and all those things. Your teams, technology teams, focus on doing the application development of how do I leverage the data to generate the insights that the business is looking for. So that gives you the faster time to market because now your teams are not really focusing on managing the infrastructure. And because we are using cloud native services, they are already optimized to give you the better performance at a much optimized cost. So it becomes from a cost point of view, it becomes a really value proposition and looking into as OpEx cost versus CapEx cost. Hadoop environment, big Azure environments are going to give you the innovation by bringing in a lot of cognitive services, artificial intelligence, machine learning kind of environments in a integrated native unified experience of leveraging these technologies on top of your big data that is coming in the world. And by doing that, you can really get the insights into the hands of everybody in the organization, not just select few. So that's really democratically turning your data insights into the entire organization. So when we talk about migration of Hadoop into Azure, and specifically leveraging by platform as a services, what are some of the offers that and technology that is available in Azure to map it? So HDFS, the Hadoop distributed file system, that's going to go into your Azure object stores, the data lake store or the blob stores that Azure provides. Your Yarn, which is yet another resource network, is basically used to manage your compute and memory to assign to the workloads. That concept really does not apply in a cloud world, and because it's going to be taken over by all the Azure Databricks runtime and then on-demand Azure Databricks clusters to manage your workload. So you really do not need a Yarn kind of concept in a cloud world. MapReduce, it's a legacy technology. Hopefully, people are already moved away from MapReduce. But if you are still using it for whatever reasons, it will be a rework required to move it. But the where it will all the workloads will land is going to be in Azure Databricks. The Spark job is a straightforward move into Azure Databricks. Azure Databricks runs same Spark technology, but much more optimized for performance. Hive workloads, it's going to move into Databricks Delta Lake technology that gives you that ACID compliance to run your workloads. All your data ingestion tools like Scoop or Flume will be moving into Azure Data Factory. Spark SQL technology is already inbuilt into Databricks, so it will move into Spark Azure Databricks. Storm is another kind of application which is now considered legacy. But if you are using it for real-time processing, that's going to move into Azure's Databricks structured streaming technology. If you are running publisher subscription model using Apache Kafka technology, that's going to be replaced by Azure Event Hub. If you are using HBase, and HBase again is another technology which is considered legacy now, but if you are still using it, it will be moving into the NoSQL columnar storage in Azure world called Cosmos DB. This will require some rework because it's not a straightforward thing, but we have the expertise. We can help you move HBase into a Cosmos DB. If you are running Impala kind of workloads for SQL queries, it's going to move into Synapse Analytics. All your permissions or authentication authorization will be taken care by Active Directory, Azure Active Directory, and the Databricks permissions. And all your SPUSI or Airflow kind of orchestration jobs will move into either you can use Azure Data Factory, or you can even also have Azure Airflow DAG installed in Cloud World. So how is that reference architecture for moving your Hadoop workloads is going to look like in Azure? So all your data ingestion is going to, if you're running in a batch mode, is going to be done through Data Factory into a ELT mode where you can bring in all your data and store them into Azure Data Lake Store. That gives you the reliable, secured, and cost-effective data object storage to store all your data. If you're running streaming the real-time job for publisher subscription Kafka kind of jobs, it will be replaced by Event Hub and bring all your data into the object store. And this is where the Azure platform starts to solve some of the challenges that we saw by implementing a structured transaction layer on top of the data lake. So which is going to be created by using the Delta Lake technology in Azure Databricks. That's going to give you the ACID compliance of giving you atomicity, consistency, and durability of your data. So any reader of the jobs of the data will not get dirty reads when the another job is trying to write the data at the same time. It allows you gives you the capability of doing updates, merge or deletes, because it's becoming the structured like SQL table kind of a technology on top of your data lake. And it gives you the high performance and adaptive query and execution way of doing this. So that really gives you the reliability in a big data world in terms of Azure. Another beauty of that is it does not have to be a solution for big data alone. So you can start small And as your data volumes keeps on growing, all of these are cloud native platform as a service. They can automatically scale and continue to give you the same performance that you used to get when you are very small. So that's a beauty of this architecture, that you do not have to plan for the high volumes at the beginning of the projects. Finally, you can use the data technology to create structured transaction on top of your data lake data, but then you start doing the data wrangling and data cleansing to transform the data and really create into the final format or the aggregates or the dimensional model, as we call it, in a gold layer, which can be copied into Synapse Analytics, Azure Synapse Analytics, to run all your business intelligence kind of workloads at a petabyte scale. So that's the combination of Databricks and then using Databricks data in Synapse Analytics to run your Power BI kind of queries or any other BI tool, Tableau or ClickView for that matter, is gonna give you that that flexibility. Azure Databricks also gives you the benefit of running unified analytics by not only having data engineers use the data lake technology to process the data, but it also gives you the data scientist unified workspace, and it gives you the pre-installed machine learning and deep learning libraries like TensorFlows, PyTorch, Keras. They all are available pre-installed into Azure Databricks. So using the same data that is being available in your data lake, data scientists can use it to run their machine learning and deep learning algorithms. And then for deploying that algorithms, you can use Azure Machine Learning to really create the models and use it in your downstream applications using that. So this becomes a reference architecture for migrating your big data workloads and giving you a unified environment to all your data engineers, data scientists, and data analysts to leverage the same platform, same tools and technology to use the data, whether it is structured, unstructured, batch, real-time, everything is taken care by the same platform, and you do not have to have data silos. So that's how I think Azure gives you starts to give you the ROI. But when we talk about migrating your existing Hadoop workloads, how do we actually do that? It's actually large Hadoop environments typically are large footprints, has hundreds of nodes that customers are running with petabytes or if not petabytes, at least several hundreds of terabytes of data they are running. They have a lot of tools and technologies available. Cloud, if you look at Cloudera, they have like 30 to 40 technologies inside Cloudera. So it's a complex environment to move, and you really need expertise of somebody who understands not only the Hadoop world, but also are the experts of the Azure world. And they have a plan, and they bring in their best practices and accelerators to really achieve the migrator. And that's where Motiveworks can help you along with our partners like Vendisco that allows you to migrate the data from your HDFS world into Azure world with zero data loss and zero disruption to your businesses. So, but what are other components that are required when we talk about migrating this Hadoop workloads into Azure? So really, it boils down into 5 different areas that you really need to think about for a successful migration of your Hadoop workloads. The number one and the biggest one is the migrating of your HDFS data. That's really a large volume, and either you can run it in batch mode or a real-time mode, but it takes time to move it. And how do you move it reliably and without any disrupting the businesses? That's where I think my partner here, Adam, is going to talk about when he's going to present momentarily, that how can Vendisco help migrating HDFS data into Azure world. Next one is going to be your workload migration and migration of your Spark jobs, your MapReduce jobs, your Hive workloads into Azure. And again, some of the things can be taken care by Vendisco, like migrating your Hive workloads. Vendisco can directly take it into data lake technology, but other workloads will move into Azure Databricks, and Motiveworks has the experience, and we can help you migrate your Spark or Scoop kind of workloads into Azure world. Next thing is around security and governance. So when we talk about security, all the authentication into Azure world, in the cloud world, will be done by Azure Active Directory. And then all your authorization of your data that currently probably you're using, like the Ranger or the Sentry in Hadoop world, that will be taken care by the access control list in Databricks and or the data lake store level. All your analytics that then you need to think about is migrating all the analytics that you're probably running it through your Hive data warehouse or Impala, and then using BI tools like Tableau or any other tools that you're using it. We need to think about, so Synapse Analytics is going to be the place, and we can help you create that gold layer in Databricks to move it into Synapse Analytics. And then the preferred way of doing the BI tool in Azure world is Power BI, but if you have Tableau environment or Tableau shop for whatever reasons, or any other BI tool, it can also be taken care by moving the analytics in Azure. And the last thing is going to be around monitoring. So Azure, in the Azure world, it provides you Azure monitoring, the application insights, and log analytics. So at Motiveworks, we have created some predefined way of getting your monitoring across all your workloads at one place, so you can have dashboards that gives you the visibility into what's happening into your big data world at one place. So quickly talk about how do we bring all of these things together and create a big data architecture. So this is a before and after picture of if you are running on-premises Hadoop environment with the HDFS nodes and using Spark to process the data, and then use Hive to run your warehouses. And you also are using publish a subscription for real-time streaming of the data in using Kafka. This is how it's gonna turn and translate into an Azure that we have done it for one of our customers. Everything is gonna run it mostly through Databricks as the unified data analytics platform, but all your HDFS data is gonna move into Azure Data Lake Store. And then you use tools like Data Factory and Event Hub to bring in your data in for this batch or streaming mode. So this is a case study that talks about how we have helped one of our customers who was a retail analytics company, who is really providing the services to the retailers and manufacturers to really understand how their products and how to price them and how to give them competitive data to start running promotions and pricing calculations in their environment. They were using on-premises Spark environments, and they were running into a lot of performance issues and support of that workloads. So we worked with them and then moved them into Azure world. And by using the same big data technology in Azure, like Databricks, we were able to increase their performance by 40% in comparison to their on-premises performance, and able to reduce their cost of running these workloads by 20%. And in addition to the reducing of 20% infrastructure cost, we were also able to reduce 40% of their DevOps resources cost by using and leveraging managed services environment and not having to need that many people. So with that, I think that gives you the good insights into how you can migrate your workloads into Azure. And I'm gonna, at this point, hand it over to my friend Adam Diaz, who's going to talk about how Vendisco can help you migrate the data into Azure.
Okay.
Adam, I'm going to make you presenter, and you should be able to share your screen.
Yes, let's make sure I can share my screen. Are you seeing my slides here?
Yes, I can see it. Perfect.
So I'm going to maximize it. And if everything looks okay, we'll go ahead and get started.
Yep, looks good to me.
Okay, sounds good. So hi, yeah, my name is Adam Diaz. I'm here today with Vendisco to talk to you about a little bit about some of the technology that we bring to the table that might be used in a workload migration case, specifically going from the Hadoop world, from the big data world into the Azure Azure Cloud. And so we've been in the business of data migration and data replication for some time. And most recently, we've come up with some new offerings that we're going to talk about today that are coming out in the Azure Marketplace. And I think the thing that makes the combined story here of MotifWorks and WANDisco relevant on specifically on this slide actually is point number 2, understanding that when we talk to the challenges of workload migration, cloud migration in general, that this problem has 2 components: the problem of getting your data there, and then also getting the analytic or the actual code that's run against that data moved over to the cloud as well. And I think Tarun did a good job in talking through the different types of challenges that you might see. You face a number of choices, right? Your choices could be a similar technology, it could be a refactoring, it could be a complete movement of that analytic or that uh, uh, thing being done to the data to a completely new thing that exists in the cloud that didn't exist on-prem before. So there's some work and consideration and careful thought and process that has to take place aside from the movement of the data. So from a responsibility perspective, WANDisco is squarely concerned with the movement and replication, consistent replication and migration of data from on-prem to the cloud in this case. We have technologies for many use cases, but the one we're talking about today is sort of that initial use case where customers say, we like to get our data into the cloud, and it's never just the data. Obviously, it is obviously the workload itself as well, and that's where we come to MotiveWorks to help us round out that offering to make sure the customer has a complete solution at the end of the day. And some of the challenges we find are that migrating data is not just a copy operation, meaning it's not as simple as saying I want all of this data to be moved from point A to point B, initiate a copy, and push go. It's really not as simple as writing, say, a Spark job to try to approximate the movement of data. It's actually quite a field of study, and especially when you mix in Hadoop and you mix in the background theory on distributed computing, you find out right away that when you move data, little problems like what happens when something, a data movement, data copy operation fails in the middle. How do you resolve what's been migrated, what hasn't been migrated? What happens when the movement of that data is complex, meaning you have change occurring while you're in the process of moving that data. So you have some options. You have options like the various, what I call hard drive in a box options from the different cloud vendors, where they'll bring you basically a large hard drive where you can copy data and then mail them that hard drive. They upload it for you. You still have a delta between what you've loaded on that drive and the time it took for the drive to arrive. That still has to be reconciled. Complexities like not only that the data could be being updated during the time that it's moved, but no matter what choice you make in movement, that it could be, the requirement is a zero downtime. You're running your business against this data. You don't have time for mailing hard drives around, and no matter what process you choose, you have to have this data and the replication be done live, which is another issue. The complexity in terms of regulatory controls, the last point. What if your data needs to be moved to more than one location? How do you, in a rational way, and reusable and understandable way codify the movement of a large amount of data from a single or multiple source locations to multiple destinations, and then at the end of the day have some peace of mind that that has been done consistently. Um, as the amount of data grows, the consistency problem becomes larger, and the problems of what happens when there's a failure in the middle of those data migration operations grows. So there's a lot of tooling. So I should specifically say a few things. One is what we do has to do with data, the data replication part of this problem. More specifically, what we do has to do with the replication of mainly Hadoop and big data side of the equation. So there's already existing tooling for smaller data. There's already existing tooling for RDBMS and other sorts of technologies to just move data into the cloud. And really the specific problem we're addressing is that problem at scale, the data replication and data migration problem at scale. It is a unique animal, and that's why we've chosen to address it. Once you get to that scale and you've tried this a few times, you begin to see the challenges, and it becomes very apparent that you need a tool. You need a tool that's very reliable in order to make it happen in a um, efficient way. There's always ways to do things by hand. There's always do-it-yourself code. But when you're running your business against something, you want your data moved. You've made that decision to go to the cloud. You want that data moved. You want it done consistently, efficiently, and as rapidly as possible. You don't want to spend a lot of time essentially reinventing the wheel with homegrown code to get your data migrated. You need to get on with the business of your actual business. So some of the core use cases, to really boil it down to very simple terminology, some of the core use cases that we see are migration. You can notice the arrow on the first use case only moves to the right. That's because when we talk about this migration use case, we mean movement from, say, an on-prem Hadoop system into object store in Azure. And so that data would only be flowing in a single direction. In the middle use case, this hybrid, so-called hybrid use case, we have additional technology that allows the bidirectional replication. Perhaps you would like to migrate an analytic, for example, but also want the peace of mind that while you are refactoring that in the cloud, you have that same data on-prem and in the cloud at the same time, allowing you a longer sort of grace period to make sure that that analytic, as it's been rewritten, has been refactored correctly and is actually working against the actual production data. So we have some technology that allows this near real-time replication, very near real-time replication of data from ground to cloud. That can also be done inside of a cloud and potentially across cloud, depending upon your use cases. And then sort of the final one, and it was really one of our original use cases, was just a real basic use case of Hadoop disaster recovery. So that's sort of part of our legacy operations. And what I was going to talk about today is simply the little bit of the background on what technology pieces we bring to the table, and then sort of demonstrate the single initial, so most sort of straightforward use case. How do I get my data from on-prem into Azure? Just get it into the object store. We can make decisions on it from that point. Do I take it to Databricks? Do I take it to HDI? Do I take it to another Synapse? Do I take it to some other technology from that point? But the object store is obviously, in terms of a data perspective, is usually your first stop. And so we'll talk a little bit more about how the technology we use to make that happen. From a larger perspective, if we take a step back from the specific use cases, the technology for Azure that we bring to the table, we talk about under the umbrella of Live Data Cloud Services for Azure. It's our umbrella name. And within that series of offerings. We have initially two products. You'll see one here called Live Data Migrator for Azure. That's the one that's going to address the use case we're going to talk about today. And another called Live Data Plane for Azure. And this one would address that secondary use case, that bidirectional replication that we talked about. Both of these exist over this thing that we call Live Data Platform for Azure. That's this gray box along the bottom. That is really a series of technologies that give us the integration points into the Azure world and the Azure services. And so these two technologies can now be run as native services. You can go right to the marketplace, look for WANDisco, look for Live Data Migrator, for example, and go ahead and start these products, install these products, and use them. Natively build to your normal subscription as a part of Azure. There's no need to negotiate a separate contract or sign a lot of things. If you have an Azure account, a valid Azure account, you can go ahead into the marketplace and start using these things today. So again, just to give you kind of a more close-up view of that diagram, what we're going to talk about today is that Live Data Migrator for Azure in the upper left-hand corner. And so to give you a little bit of background on what does that actually look like? Well, from a very simple perspective in this diagram, you can see Live Data Migrator is a technology that we would actually run on-prem. So when you go to the a marketplace, the Azure marketplace, it does actually install and kick off some technology that does run in the cloud, but for the most part, the thing that's running, the actual code that's moving your data is exported from that offering and carried down to, in this case, an edge node near your Hadoop system on-prem, and then it connects back to Azure and pushes that data to a configured storage layer, ADLS Gen 2 storage layer in the cloud. And so that's, again, a one-way migration back into the cloud. And we contrast that with this sort of an architecture where that second offering, that data plane offering, actually has something running both in the cloud and on-prem to make the bidirectional nature of that replication happen. So it's a little bit, requires a little bit more infrastructure, but again, slightly different use case, slightly larger technology, but again, very configurable, and usually the natural second location, the second stop for people once they understand to a large degree the difference between the two technologies. The platform itself has a series of capabilities for a series of plugins that enables us to extend the technology to enable and encompass other use cases. One great example of that is this offering that we have called Live Data for Databricks. And so that enables us to take, for example, not just HDFS data, but which is already just the base use case for us, movement of HDFS data to object store. What if you had Hive and you also wanted the metadata for those tables? We have essentially a Hive plugin that interfaces with a plugin that we've created for the Delta Lake, which does a conversion to Parquet format, sort of the native storage format for the Delta Lake, as well as pushes the metadata for the table all the way from on-prem into an object store as a sort of a stopover, and then that conversion takes place, and then the movement of the data into the Delta Lake. So one could sit on the on-prem side of this equation on the left and be updating tables live in the Hive format, and then you can have analysts on the far right interacting with their version of Databricks and having that data available to them just about as fast as you can load the data on the left-hand side. So that's the nature behind the product naming, the live data, that really the people say, I've heard people call it, what is your superpower? When you talk about someone's technology, what's the thing? What's the gotcha? What is the core thing that you do? And the core thing that we do is when we talk about the movement of this data, the core thing that we do is we make that data available live. We make that the copy operations, the movement of this data is not only quick, but it is done in a live way such that you can utilize your data in one or more locations, without having to suffer a severe downtime or large delays. And so, what are the other benefits? What are the things that we're bringing to the table? I think we talked about lack of downtime. We talked about data consistency. I think the other nice thing that we're bringing to the table is a lack of, I think, which is really important. And I don't think a lot of people think through this until they understand. I'm trying to move 10 petabytes of data off of HDFS. This is going to take some time. We're not, the way that the solution is architected, we're not competing for resources on the cluster. So we're not launching a MapReduce job to move data like some of the native methodologies for moving data off of Hadoop. I think we're bringing automation. We're bringing the capability to move this data in a continuous fashion. Again, so there isn't this large offline requirement for movement of data. And you have this capability of creating simple rules that say, this is the data I want moved, I want this data excluded, and push go, and do that from a UI. Or if you want, scripted methodologies, or you need an API, those things are available as well. But the base use case for having a simple ops person sit there and create these rules and push go and have that data moved, it's very easy to do. And we're going to show that in just a second. So what we see here is what I'm going to show you as if we were doing this in real life. This is sort of the architecture we would have. We would have live data migrator installed on this edge node near the Hadoop cluster on-prem, and it would probably use something like ExpressRoute to get that data into the cloud and into your ADLS Gen 2 object store. In the interest of full disclosure, the way we demonstrate this is we actually use a Docker-based system that enables us to rapidly install, configure, manipulate, break it if we need to, these types of systems for demonstrations, prototyping, POCs, what have you. We use this container-based system to simulate this. So actually what we do is we install a VM on Azure, we install Docker, and then we install our instances, our containerized instances of this tech right inside of that system. So what I'm going to show you is actually looks like this. And so all of the movement is accurate. We are running Hadoop, we are running HDFS, we are running our technology, and that is writing to ADLS Gen 2. But I like to show that just in the interest of full disclosure. So I will stop that, and I will actually come over here quickly to a web browser and show you this is the actual user interface for this technology that we're showing here called Live Data Migrator. And what you're looking at here is in the upper right hand corner, the storage location. So you can see that when we installed it, it auto discovered the source cluster, and that's because where this is naturally installed, again, as an edge node, that edge node naturally has not only the client bits for being a consumer of the HDFS cluster, but it also has the specific connection information that allows it to connect to whichever cluster it's associated with. And so that's pretty easy to auto discover that. And then, so that's the source. And the second item then is the destination. If you drill into one of these If you have more, they'll be obviously listed there. But you provide the connection information. So ADLS Gen 2 is real straightforward. The storage name, the account name, what's the container name, and the access key. And we're sort of off to the races. Once these two things are defined, a source and a destination, we can go down and we can look at the different rules. So these are some of the rules that I created previously. And then you can see this is the Embari. This is an HDP system. Again, we have that running inside the Docker system. If we looked at from an Azure perspective, this is that same configured container, ADLS Gen 2. So I'm in the Storage Explorer here. I'm inside of this account number 4 that I have, the storage account 4, and I'm in the Atom 4 container. And these are previous migrations that I've done. And so from a interface perspective, this could obviously be done at the command line. Just to make it nicer for the demonstration, I use the Hue file browser. And if we say, I'd like to create another directory, let's just call it migration 5. And let's go into the old directory here, and let's take some of this data and move it to directory 5 so that there's some existing data. Again, the normal use case here would be we would be in the, let's go back out to 5, make sure there's data here now in this migration 5. The normal use case is we'd be in this interface and we would say, okay, I have some data I'd like to go to the cloud. I've configured a source, I've configured a destination, and I can go down here and say add a rule. I have one source, I have one target, and then we'll say what is the path on HDFS that we want migrated. We can say we'd like to auto start that migration. If you like to exclude data, you can do that here. There's some patterns. These are just simple, normal, regular expression patterns that you can create. So there's some examples here already that you can select from. You can add them here if you'd like to. You have some control over the behavior based upon some metadata, whether you'd like to overwrite files or whether you'd like to skip them. But essentially, that's pretty much it. You say, this is the data I want, which is everything. You exclude some data, which you don't want to have moved. We say create, and you'll see the bandwidth usage goes up immediately, showing you that there's some movement happening. So we look at migration 5. If we go into that and take a look at it, it says, okay, there was some pre-existing data moved. I moved 4 files. This was the size, total amount of data moved. And here's the exclusions that were included. And it's currently running because you see this, there's this button that says stop. And it says, okay, it started a few seconds ago. So if we had obviously, 50 terabytes of data in here, 100 terabytes of data in here, you'd see these stats changing. Just for the interest of a quick demo, if we go back out here, now we say refresh, we get migration 5, and then those same 3 files that we had put in to this original directory. And so that's nice. So you've pointed at a directory and you've moved some files, you've configured this, but now let's say you actually have a production workload and you actually have additional things being moved. Let's just pick something here, any file has been kicked off. And so now I've written a new file to that directory, and when Disco and this technology is smart enough to understand that another file has been written, so it's based upon an event notification, a file's been written there, go ahead and move that. And if we give it a second, you'll see that same file shows up. So it's doing two things. You're pointing it at a directory of existing files, which could be a complex hierarchy of large amount of data with very intricate large numbers of files. And then it's also monitoring for the late arrival of data. And what you'll find is that using this type of system, a single initial scan of the data plus waiting on event notification for additional updates of data to that directory structure will get you to the endpoint of all my data consistently migrated the fastest. A lot of the other methodologies for doing this rely on scanning of source, scanning of data, resolution of the two locations, and then a eventual consistency. That type of algorithm approaches consistency eventually, whereas this provides it in sort of one pass. Why does that matter? It matters because when you're migrating a petabyte or 10 petabytes of data, you don't want to go back and rescan your data. You want to we're talking about the difference between 8 months versus 8 weeks. And that's how this sort of problem multiplies itself out. And so I'll wrap up here. I think we're sort of getting to the end of our time here, and I wanted to make sure to show you, again, we have this data lake migrator for Azure available today in the marketplace, and to go ahead and also more importantly let you know that we have a combined offering. So to get you that holistic solution of having your data moved and then having someone to also help you to navigate the decision making around how does the analytic get refactored or repurposed, and that along with the analysis of how much data do I have, how fast does it need to be moved, do I have regulatory requirements, can it be in one zone or not another zone due to legal ramifications. All those decisions are things that our friends at MotifWorks can help you do. So I think I'll move on here to the Q&A portion if there's additional questions.
Thank you so much, Adam, and thank you, Tarun, as well. I know that we are cutting it pretty close on time, so what I'm going to have everyone do is if you have any additional questions, please feel free to reach out to us. You can email us. It's Tarun, T-A-R-U-N, @motifworks.com, or adam.diaz, D-I-A-Z, @wandisco.com. And you can also feel free to visit the MotifWorks or the WANDisco website. Contact information is on there. But feel free to please send us all of your questions and we will get back to you as soon as possible with answers. Thank you so much for attending the webinar, and we look forward to seeing you at future webinars. Thank you again, Tarun and Adam.
Thank you, Sarah, and thanks, Adam. Great presentation.
Thank you.